In Chapter 4.6, what we're going to talk about is how to solve equations involving factoring. For the most part, we'll be factoring trinomials, but in some cases, like number 24, we're going to factor a binomial, but that's a special case binomial. And what we're going to end up with are two solutions that work for each one of our equations. In the first case, number 6, we have a fairly simple equation here involving the trinomial x squared minus 5x plus 4. And what we want to know is what two numbers when multiplied together give me positive 4, but when combined give me a negative 5. And those are x minus 4 times x minus 1. When we get that equal to 0, now we set each of the binomials equal to 0. So x minus 4 equals 0. Adding 4 to both sides, what we get is x equals 4. Then we take our other binomial, x minus 1 equals 0. Adding 1 to both sides, we get our second solution, which is x equals 1. Going on to number 24, what we have is a special case there, and we know that that's x plus 7 times x minus 7 equals 0. Now we set each of those binomials equal to 0, so x plus 7 equals 0. Subtracting 7 from both sides, we'll get x equals negative 7. And when we take the other binomial, x minus 7 equals 0, add 7 to both sides, we will get x equals 7. Those are fairly simple and straightforward, but now we'll take a look at a couple that are a little more complex. Let's look at number 36. What we have is 5x squared minus 55x equals 60. But we don't have it equal to 0, and what we need to do then to get it equal to 0 is subtract that 60 from both sides. What happens when we do that is we get 5x squared minus 55x minus 60 is equal to 0. Now, we do have a common factor we can pull out of there, and that's the 5. When we pull that 5 out, we get x squared minus 11x minus 12 equals 60. Now we can factor, and what two numbers when multiplied together give me a negative 12 and when combined give me negative 11. That is x minus 12 times x plus 1. Now we're ready to set each one, and we don't worry about the 5. All we do is take the x minus 12 equals 0 and add 12 to both sides. We get x equals 12. When we do the x plus 1 equals 0 and subtract 1 from both sides, we get x equals minus 1. So that's the solution to number 36. In number 54, we've got a binomial times a binomial, so the very first thing we have to do there is the FOIL system. We're multiplying x times x, we get x squared minus 2x plus 3x minus 6 equals 14. Now we combine the middle terms, and so we get x squared plus x minus 6 is equal to 14. We still don't have it equal to 0, so we have to subtract 14 from both sides. When we do that, we end up with x squared plus x minus 20 is equal to 0. Now we say, what two numbers multiplied together give me negative 20, and then combined give me a positive 1, and we know that that is x plus 5 times x minus 4 equals 0. Setting x plus 5 equal to 0, subtracting 5 from both sides, one of our solutions then is x equals negative 5. Putting x minus 4 equal to 0 and adding 4 to both sides, the other solution is x equals 4. All right, now we're ready to take a look at problem number 56, which is more interesting. Here we're multiplying 3x minus 5 times x plus 2, and when we do that, when we FOIL, we get 3x squared plus 6x minus 5x minus 10 equals 14. Combining the middle terms, we get 3x squared plus x minus 10 equals 14. But get it to equal 0, we have to subtract 14 from both sides. And now we get 3x squared plus x minus 20 equals 0. Now, because we have a term in front of the x squared, we'll have to use the AC method. And our first is a 3 and times minus 20. That will give us a minus 60. All right, what two numbers, when multiplied together, give us minus 60, and the difference of which is only 1? Let me see here. We have, oops, I'm sorry. When I combine those two, this should be 24. So this should be 24, and that should be negative 72. My fault. My addition is bad. Let's go back and erase that and make sure that we have that as the correct number, negative 24. So now when we multiply 3 times negative 24, we get negative 72. That combination would be 9 times 8. So we get 3x squared plus 9x minus 8x minus 24 equals 0. I'll carry that off to the right, but when we factor the first group, what we get is 3x times x plus 3. And factoring out the negative 8 here, what we get is x plus 3. Now what we have are x plus 3 times 3x minus 8. And that all equals 0. In our first term, x plus 3 equals 0. We just subtract 3 from both sides and we get x equals negative 3. In our second one, when we have 3x minus 8 equals 0, and add 8 to both sides, what we get is 3x equals 8, and then 3x over 3 equals 8 over 3, or x equals 8 over 3, or 2 1/3. So those are the two factors that work for number 56. Now what I want to do is take a look at a couple story problems. So what I'm going to do is erase quite a bit of what we got here and take a look at a couple story problems that are on page 288. The first is at the top of that page, and it's problem number 58, which involves a couple of numbers. Let me get this erased and we'll talk about that. All right. It's just erasing these right here. In number 58, what it says is that we have the sum of two integers is 12 and the product of the two integers is 27. Now, in doing story problems, what I always say is let x equal. So we'll say let x equal the first integer. We'll substitute int. If these two together make 12, and I subtract that first integer from 12, I subtract that x, I get the second integer. Now it says Once I know that, I've defined that, the product of those two is 27. So what we're going to do is we're going to take the first integer, x, times the second integer, which is 12 minus x, and that equals 27. All right? When we multiply through, we get 12x minus x squared equals 27. Well, now we've got a negative x squared. Now, that's not going to work too well. So what I want to do is I want to add x squared to both sides. That gives me a positive x squared on the right, plus 27. We still have 12x on the left. So I want to subtract that 12x. When I do that now, arranging in order, I'll get 0 equals x squared minus 12x plus 27. All right? We have pattern number 2, as you recall from back in the days talking about factoring. In this case, we have what two numbers when multiplied together give me 27, a positive 27, but when combined give me a negative 12. And those two numbers are x minus 9 times x minus 3. Now we can set each one of those equal to 0. And I'm going to do that over here on the left. X minus 9 equals 0. Add 9 to both sides. And I get x equals 9. Putting x minus 3 equals 0. Adding 3 to both sides. I get x equals 3. So, if our first integer happens to be 9, and 12 minus 9, what do we get? 3. Or, if we wanted to use the solution 3, 12 minus 3 gives us 9. So the two answers are 9 and 3. So there, we've solved that problem. Now let's take a look at a geometry problem. In this geometry problem, what we've got is we've got a rectangle. And it says in problem number 66, if the length of a rectangle is 3 feet less than twice its width and the area is 54 square feet, what are the dimensions of the rectangle? So what I like to do is draw my rectangle. I have a width and I have a length. And it says about the length that it's 3 feet less than twice the width. So if I let the width equal x, then I know my length is 3 feet less than twice that, 2x minus 3. And if we recall from our days of studying geometry, the area is equal to the length times the width. Or our area of 54 is equal to the length 2x minus 3 times our width, which is x. Now, realize that in form that's sort of backwards, so we can always, because of the commutative rule, flip that around and make it x times 2x minus 3. When we multiply that across, we get 2x squared minus 3x. So now we know our 54 square feet is equal to 2x squared minus 3x. But we need to set everything equal to 0, so we have to subtract 54 from both sides. What we get is 0 equals 2x squared minus 3x minus 54. In this particular case, now to factor, what we have to do is we have to use the AC method. A times C. In this particular case, it's 2 times a negative 54. And what that gives us is a negative 108. So the question is, what two numbers when multiplied together will give me negative 108, but the difference of which is 3? And it just so happens that those numbers are 9 and 12. And so what we're going to do is set this up as 0 equals 2x squared minus 12x plus 9x minus 54. In that first set, now we're factoring by grouping, what we have is 0 equals 2x times x minus 6. And the second factor, we have plus 9 times x minus 6. So now what we have is 0 equals x minus 6 times 2x plus 9. In the solution of this, if we take x minus 6 and set that equal to 0, we add 6 to both sides. What we get is x equals a positive 6. With the other part, when we take 2x minus 9 and set that equal to 0, we'll come up with a value of x equals negative 9 over 2, or negative 4.5. Negative numbers don't work. And if we take a look at our solution of 6, if the width is 6 and the length is 6 times 2 is 12, minus 3, 9. 9 times 6 is 54. That gives us our answer. So here, our width happens to be 6 feet, and our length, which is equal to 2x minus 3, is equal to 12 minus 3, or 9 feet. So there we solved a geometry problem. Pretty interesting exercises there in 4.6.